Hi friends, do you know that mirrors are of different types? Plane mirror and curved or spherical mirrors. Spherical mirrors can be further divided into concave mirror and convex mirror. So there are three types of mirrors: plane, concave and convex. In fact, I have all these three mirrors on this wall here for you. I'm going to go and stand in front of each of these mirrors and let's see what do we observe. If I stand in front of the first mirror, I appear to be the same height. If I stand in front of the second mirror, oops, I appear to be inverted. Now if I move close to the mirror, I appear to be magnified. Now if I stand in front of the third mirror, I appear to be shorter. Can you guess the type of mirror for each of these? That's right. The first mirror is a plane mirror. The second mirror is a concave mirror. And the third mirror is a convex mirror. Let's talk about the three mirrors. A plane mirror has a plane or flat surface. And I'm sure you must have noticed that when you stand in front of a plane mirror, you appear to be the same height. Now let's look at concave and convex mirrors. These mirrors are curved mirrors. And a very simple way to understand them is using a spoon. So I'd like you to pause the video right here and go and get a spoon. And it'll be great if you can get a large and shiny spoon. So are you ready with your spoon? A concave mirror is curved inwards. So if you look at this side of the spoon, can you see it is curved inwards just like a concave mirror? Now hold the spoon like this and look at yourself in the spoon. What do you observe? You appear to be inverted and smaller in size or diminished. Now if you bring the spoon really close to yourself, you can see that you are looking magnified. But an easier way to do this is to hold an object like a pencil and get it really close to the mirror. Now you can clearly see the magnification. So a concave mirror is the only mirror that can produce an inverted image in this position or a magnified image. A convex mirror is the opposite of a concave mirror. So if we flip the spoon, here we have a convex mirror. Now if you look at yourself on the convex side of the spoon, what do you notice? You appear to be smaller, but your image is now straight or upright. And no matter where you move the spoon, the image in a convex mirror is always diminished and upright. So this was our quick recap on the three mirrors. More details on spherical mirrors coming up later in the video. But first let me ask you, which types of mirrors are you using in your daily lives? I'm using all three types of mirrors every day. If you don't believe me, I'll be showing you some clippings from my daily life. And you need to be a detective and identify the type of mirror. Is it a plane mirror, concave mirror, or a convex mirror? Are you ready? Let's start. In the morning, when I shave, which type of mirror am I using? The shaving mirror is a concave mirror. The face in the mirror is magnified. If I flip this mirror, there's a plane mirror behind this. Can you see the difference in magnification between the plane mirror and the concave mirror? When I comb my hair, which type of mirror am I using? This mirror has a flat surface. It's a plane mirror. When I leave the house and go down in the elevator, which mirror does the elevator have? It's a plane mirror. To save time, I can actually comb my hair on the way down. While driving the car, I use the two mirrors, the rear view mirror and the side mirror. which types of mirrors are these two mirrors? That's right. The rear view mirror and the side mirror are examples of convex mirrors because they give a greater field of view. There are mirrors kept at road intersections so that you can see the vehicles coming from the other side. Which type of mirror are these? That's right, convex mirrors. So as you can see, I'm using all three types of mirrors every day: plane, concave and convex mirrors. Concave and convex mirrors are together called spherical mirrors. Now, do you know why they are called spherical mirrors? If I take this ball, it has the shape of a sphere. Now let's imagine the surface of this ball to be shiny like a mirror. I wish I had a silver colored ball, then it would actually look like a mirror. Now if I take this knife and I cut the ball here, this slice is a curved mirror. It's called a spherical mirror since it's come from a sphere. If the inside portion is polished, it's called a concave mirror. If you polish the outside portion, it's called a convex mirror. An easy way to remember the concave mirror is, it's as if you're entering a cave. It's a hollow portion. So this side is a concave mirror and the opposite side, which is bulging, is a convex mirror. The concave mirror can be represented by this simple diagram where the smooth side is the shiny reflecting surface. The side with these small dashed lines is the back of the mirror. Similarly, for the convex mirror, the smooth side is the shiny reflecting surface and this side is the back of the mirror. Now an interesting question is, why these mirrors behave differently? To understand, let's imagine we are throwing a parallel beam of light on all the three mirrors. Let's start with the plane mirror. So if you throw the parallel beam of light, can you see that the light rays remain parallel even after reflection? Next, let's try the concave mirror. Now if you throw the parallel beam of light, can you see that the concave mirror converges the light rays to a point? The concave mirror is a converging mirror. And now let's look at the convex mirror. So if you throw the parallel beam again, can you see that the convex mirror is diverging the light rays? So the convex mirror has a diverging action. It's a diverging mirror. Here's a comparison table of a plane, concave and convex mirror. Now you must be thinking, why curved mirrors converge and diverge light rays but a plane mirror does not? Is it because these laws of reflection hold only for a plane mirror and not for curved or spherical mirrors? What do you think? The answer is, the laws of reflection always hold for both plane and curved mirrors. Let's take a closer look. So if you draw the normals at each of the points of incidence for the light rays, the angle of incidence is always equal to the angle of reflection. But the concave and convex mirror have a converging and diverging action because of their curved shape. It's due to their curvature that the light rays reflect in this manner. There are some important terms for spherical mirrors. For example, pole, focus, center of curvature, principal axis, and so on. Let's understand these terms with the help of a simple diagram. Let's start with the concave mirror. The center of curvature is the center of the hollow sphere of which the mirror is a part. The center of curvature is represented by C. The center of the surface of the concave mirror is called the pole, represented by P here. Radius of curvature R is the radius of this sphere. The straight line passing through the center of curvature and the pole is called the principal axis. The portion of the mirror where the reflection of light takes place is called the aperture of the mirror, represented by mm dash here. Remember, the concave mirror is a converging mirror. If a beam of light that is parallel to the principal axis is incident on the concave mirror, after reflection, the rays meet at a point on the principal axis. This point is called the focus, represented by F. The focus is exactly in the center of P and C. The focal length F is the distance between the pole and the focus. So focal length equals radius of curvature by 2. Now let's take a look at the convex mirror. Center of curvature is the center of the hollow sphere of which the mirror is a part, represented by C here. Note that the center of curvature of a convex mirror lies behind the mirror. The center of the surface of a convex mirror is called the pole, represented by P here. Radius of curvature R is the radius of this sphere. The straight line passing through the center of curvature and pole is called the principal axis. The portion of the mirror where the reflection of light takes place is called the aperture, represented by mm dash here. Remember, the convex mirror is a diverging mirror. If a beam of light that is parallel to the principal axis is incident on the convex mirror, after reflection, the rays appear to diverge from a point on the principal axis. This point is called the focus, represented by F. The convex mirror has a virtual focus, since the focus lies behind the mirror. The focus is exactly in the center of P and C. The focal length F is the distance between the pole and the focus. So focal length equals radius of curvature by 2. Let's place the label diagram of a concave and convex mirror on our concept board. Now that we are done with the concepts, are you ready for the top 3 questions on this topic coming up for you right now? Friends, try solving these questions and let me know your answers and doubts by putting it in the comments below. I make a commitment to reply to all your comments as soon as possible. So I'm going to disappear and you pause the video here and give these questions a shot. I hope the concept of spherical mirrors is super clear to you now. Remember, our spoon is both a concave and a convex mirror. I would also encourage you to look for the different types of mirrors in your daily lives. For example, do you know the torch has a mirror inside it? Which type of mirror is that? And what about the mirror in your dentist's office? Or the mirror on the streets and in the street lights? Do let me know what you find by putting it in the comments below. And do remember to subscribe to my YouTube channel and follow my Facebook page. And do check out my website, manochaacademy.com. Thanks for watching.